In today's lesson, we will cover the integration as summation of areas. So in this subtopic, we're going to have to look at three um, sections. The first one is area of region between the curve and the x-axis. Okay, area of region between the curve and the x-axis. Suppose that we have a curve. And this is your x-axis. Okay, if you want to find the area of the shaded region, so area of the shaded region is just equals to integration from a to b of the function y with respect to x. Okay, in other words, it's just integration from a to b of the function f of x with respect to x. Why is it with respect to x? Because the boundaries is on the x-axis. Okay. Again, if we want to find the area of the shaded region, we need to integrate the function y from boundaries from a to b with respect to x-axis. X-axis with respect to x-axis because the boundaries lies on the x-axis. Or in other words, we we integrate from a to b of the function f of x with respect to x. The difference between both pictures, if you see, since the area is on the top above of the x-axis, we will get a positive value. If the area below x-axis, we will obtain negative value. Okay, let's have a look on how to apply this concept in the question. Okay, suppose that we want to find the area of the shaded region here. See, okay, area of this shaded region. Again, this x-axis boundary starts from 0 until 2. Means that we need to integrate area of the shaded region. It's just we need to integrate from 0 until 2 of the function y with respect to x. So it's just equals to integration from 0 until 2 of 2x minus x squared with respect to x. So just integrate like usual. We will get 2x squared over 2 minus x to the power of 3 over 3 and put the boundaries to 0. So if we simplify, we will get x squared minus x to the power of 3 over 3 to 0, which is just equals to top minus bottom. Substitute 2 squared minus 2 to the power of 3 over 3 minus with 0 squared minus 0 to the power of 3 over 3. If you press your calculator, calculator, you should get 1/3 units squared. And obviously it's positive because area lies above x axis. Okay, let's try one more example. We want to find the area of the shaded region. It's just equals to integration from 1 until 3 of the function y with respect to x, which is just equals to integration 1 until 3 of x plus 2 over x squared with respect to x. And remember, integration 1 until 3 of x plus 2x to the power of -2 with respect to x. So we integrate like usual. We will get x squared over 2 plus 2x power of -2 plus 1 over -2 plus 1, 3, 1. And which is just equals to x squared over 2 plus with 2 to the power of x to the power of -1 over -1, okay, which is just equals to x squared over 2, positive negative becomes minus 2 over x, 3, 1. I just simplify things, which is just equals to 3 squared over 2 minus 2 over 3. So this is the top one, minus with bottom ones. So we get 1 squared over 2 minus 2 over 1. The final answer should be let's see. Just press your calculator. I need to find my calculator. 3 squared over 2 minus 3. So the answer is 16 over 3, which just equals to 1 over 3 units squared. Again, it's a positive value because the region lies above x-axis. Okay, find the area of the shaded region. Suppose that I name the first area as area A and second area is area B, and we try to find both area separately because area A will produce a positive value, area B will produce a negative value since area B is situated below the x-axis. So once we have the area, one area is positive, the other area is negative, we have to do it separately, then only we add both areas. Which means that before we start our integration process, let us first expand the equation y equals to x plus 1 times with x minus 2, expand as usual. So what you need to do is you need to first multiply that, so it becomes x squared plus x, multiply with x minus 2, then x squared times with x minus 2 plus x times with x minus 2, so becomes x to the power of 3 minus 2x squared plus with x squared minus with 2x. So in the middle here we can simplify, becomes x to the power of 3, this one becomes negative 2 plus 1, so negative x squared minus with 2x. Now we find the area A. It's just integration from negative 1 until 0 of y with respect to x. Since the boundaries is on the x-axis, so we integrate with respect to x, which is just equals to integration from negative 1 until 0 of x to the power of 3 minus x squared minus 2x with respect to x, just equals to x to the power of 4 over 4 minus x to the power of 3 over 3 minus 2x to the power of 2 over 2, negative 1, 0. This we can simplify, becomes x to the power of 4 over 4 minus x to the power of 3 over 3 minus x squared. So what we need to do now is to insert top minus bottom. So becomes 0 to the power of 4 over 4 minus 0 to the power of 3 over 3 minus 0 squared minus with negative 1 to the power of 4 over 4 minus with negative 1 to the power of 3 over 3 minus with negative 1 squared. So we will get 0 minus with let me see. Sorry, I need to use the calculator. So this will be negative 5 over 12. Final answer should be 5 over 12 for area A. And next, as expected, area A will be positive. So yes. Now we try to find area B. It's area B. So area B is just equals to integration from 0 until 2 of the same function y with respect to x. So integration from 0 until 2 of x to the power of 3 minus x squared minus 2x with respect to x. And we know that we already found the integration just now. So it becomes x to the power of 4 over 4 minus with x to the power of 3 over 3 minus with x squared to 0. So which means that top minus bottom, we have 2 to the power of 4 over 4 2. minus with 2 to the power of 3 over 3 minus 2 squared minus with bottom 0 to the power of 4 over 4 is just 0, 0 to the power of 3 over 3 is just 0, minus 0 to the power of 2, so it will become negative 8 over 3. So as expected, area A will be positive, area B will be negative. But we want the total area. So total area, which means that area A plus with area B. So which means that 5 over 12 plus with modulus of negative 8 over 3. Why do we modulus? Because we don't have negative area. The negative value comes because area of B is situated, it lies below the x-axis, but we do not consider the negative value, we just take the positive value. So in other words, it's just 5 over 12 plus with 8 over 3. Final answer should be 1 over 12 unit squared. Okay. Now we have a look at area of region between the curve and the y-axis. So we have the curve and the y-axis. Okay, if we have a curve and the y-axis, means that the boundaries lies on the y-axis. So if we have this kind of case, so if we have a curve and the y-axis as boundaries, then the area of shaded region is just equals to integration from a to b of the function x with respect to y. With respect to y means that the boundaries lies on the y-axis. Okay. Similar to the second picture, so the area of the shaded region is just equals to integration of the function x with respect to y, with boundaries from a to b. For area of these two, on the right hand side of y-axis, we will get positive area. Left hand side will produce negative area. Okay, so this is positive area, negative area. Positive because on the right hand side of y-axis, negative because on the left hand side of y-axis. Now let's have a look at the example question. Suppose that we want to find the area here. Area here is bounded by the curve and the y-axis, such that boundaries on the y-axis starts from 0 until 3. So again, to find area of shaded region, we need to integrate from 0 until 3 of the function x with respect to y. Okay, function x with respect to y. Normally, we will have integration from a to b of function y with respect to x if we have region bounded by the x-axis. But in this case, the region is bounded by the y-axis. Therefore, instead of using y dx, we use x dy. Okay. So therefore, the problem is we have equation y squared equals to 3x minus 2. But we don't want y. We want the function, we want x. Okay. So what we need to do is we need to make x as subject matter. So just rearrange this to become y squared equals to, y squared divided by 3 equals to x minus 2. Therefore, x equals to y squared over 3 plus 2. So in this case, we have x equals to y squared over 3 plus 2, that is x equal as a function of y. So substitute this here. Okay, so this is just equals to integration from 0 until 3 of y squared over 3 plus 2 with respect to y. So we integrate as usual. Okay, let me resize this first. So what we do, we integrate as usual, becomes equals to, let me write like this, 0 until 3 of 1 over 3 y squared plus 2 with respect to y. So now we integrate, becomes 1 over 3 times y to the power of 3 over 3 plus with 2y, 0. Simplify this, becomes y over 3, y to the power of 3 over 9 plus with 2 plus with 2y, 0. So start with the top one first. So 3 to the power of 3 over 9 plus 2 times 3 minus with bottom 0 to the power of 3 over 9 plus with 2 times 0, which is just equal to 0. So we will get equals to, final answer, you just press your calculator, you should get 9 units squared. Okay, notice that the shaded region is on the right hand side of y axis, therefore the value should be positive, value of area should be positive. Okay, let's try another question. So we have x equals to y minus 1 times with y minus 4. So what you need to do here, you need to first expand both of these, which is equal to y times y minus 4 minus 1 times y minus 4 equals to y squared minus 4y minus y plus 4 equals to y squared minus 5y plus 4. So again, we have a region bounded by the curve and the y-axis, where the boundaries A to B lies on the y-axis. So which means that if you want to find area of shaded region, it's just equals to integration from, in this case, 1 to 4 of the function x with respect to y. Why with respect to y? Because the boundaries lies on the y-axis. So just now we already find x in terms of y, so just substitute here. So we have integration from 1 to 4 of y squared minus 5y plus 4 with respect to y. Integrate as usual becomes y to the power of 3 over 3 minus 5 y to the power of 2 over 2 plus 4y box 1 until 4, and as usual we need top minus bottom, so equals to top, so it should be 4 to the power of 3 over 3 minus 5 times 4 to the power of 2 over 2 plus 4 times 4 minus with settle top minus with bottom 1 to the power of 3 over 3 minus with 5 times 1 to the power of 2 over 2 plus 4 times 1, so which is equals to, you just press your calculator, you should get negative 9 over 2 units squared, but we don't have area negative. The negative symbol because the area is on the left hand side of y-axis. So in other words, basically there is no negative area, so the answer should be area of the shaded region is just equals to 9 over 2 units squared. Alright, now we are going to look at the area of region between the curve and a straight line. Curve and a straight line. So we want to find the region between a curve, and this straight line, which means that we want to find this region here. The thing that we need to know the boundaries. Okay, in other words, the value of A and B. So what happens here at point A and point B, the equation of the straight line is equals to equation of the curve. So say I name equation of straight line as y1 and equation of the curve as y2. So at point A and B, won't say at say point A and point B. At point A and B, equation of the straight line is just equals to equation of the curve. So we can say that 3x minus 1 equals to x squared plus 1. So we need to find the values of x. What I will do, I will bring everything to the right hand side. So 0 equals to x squared plus 1 minus 3x plus 1 becomes x squared minus 3x plus 2. Then I factorize x minus 2, x minus 1 equals to 0, which means that we have x minus 2 equals to 0, so x equals to 2, and x minus 1 equals to 0, so x equals to 1. Now we have the boundaries, x equals to 1 and x equals to 2. The next part, we want to find the area of the shaded region. The way I do it is always like integration of the top line minus integration of the bottom curve, top minus bottom means that we want to find the area of shaded region equals to integration from the boundaries is 1 until 2 of top minus bottom with respect to x. Why with respect to x? Because the boundaries lies on the x-axis. So integration from 1 to 2 of the top equation is 3x minus 1 minus with the bottom function is x squared plus 1 with respect to x. So you just simplify whatever in the bracket. We have 3x minus 1 minus x squared minus 1 with respect to x. So becomes 1, 2, 3x minus 1, 3x minus 2 minus with x squared with respect to x. Okay, let me check. Okay. Now we integrate as usual, becomes 3x squared over 2 minus 2x minus x to the power of 3 over 3. Boundaries from 2 to 1. As usual, top minus bottom. So we have 3 times with 2 squared over 2 minus 2 times 2 minus 2 to the power of 3 over 3. So settle with the top one minus with bottom one. So we should get 3 times with 1 to the power of 2 over 2 minus 2 times 1 minus 1 to the power of 3 over 3. So we have 3 times with 4 over 2 minus 4 minus 8 over 3 minus with 3 over 2 minus 2 minus 1 3 and equals to let me just press my calculator. Negative 2 over 3 minus with negative 5 over 6 you should get 1 over 6 unit squared for the area of the shaded region. Again, top minus bottom here. Alternatively, we can, from before, we know that this is 1 until 2 when we let 3x minus 1 equals to x squared plus 1. So when we factorize, we will get x minus 2, x minus 1. So we will get x equals to 2 and x equals to 1 when we let y of 1 equals to y of 2, y1, y2. The other option that we can do, we can use the the area of trapezium, means that if you want to find the area of shaded region, this is just equals to area of the trapezium here, minus with, okay, trapezium, minus with area below the curve, means that minus with area below the curve, which looks like that. Okay. To find the area of the trapezium, we need to find the height here. And obviously, this is if x equals to 2, at here, coordinate of x equals to 2. When x equals to 2, insert inside this formula. So we have 3 times 2 minus 1, which is 5. Means the corresponding coordinate of y is 5. Means that the height of the trapezium is 5. And when x equals to 1, then we have 3 times 1 minus 1 equals to 2. So coordinate of y2 means the height of the trapezium is 2. So we have 2 units. The height here is 5 units. And length here is 1 unit. Means that area of trapezium is half times 2 plus 5 times with height is 1 minus with area under the curve is just integration from 1 until 2 of the function below the curve. The function of the curve means that equals to integration of function of the curve x squared plus 1 with respect to x. So the first part we will get 7 over 2 minus with integration of this one, we should get x power 3 over 3 plus x to 1. So we need to solve this part. Equals to 7 over 2 minus with top should be 2 to the power of 3 over 3 plus 2 minus with, so settle with that, bottom 1 to the power of 3 over 3 plus 1. So both of these will produce 10 over 3. So we still get the same answer, which is 1 over 6 units squared. So it doesn't really matter if you want to use the first way, which is top equation minus bottom equation, then you integrate, or you want to use trapezium minus equation below the curve. Both method still will produce the same answer. Okay, let's try one final answer. So we want to find the area of shaded region bounded by the curve. If you see, this area is bounded by the y-axis. Okay, so which means our boundary starts from 0 until 2. Okay, we do not have the area of the equation of the straight line, but what we can do here is that to find the area of shaded region is just equals to the whole area below the curve from 0 until 2 minus with the area of the right angle triangle. So if you look at the right angle triangle, this height is 2 units and the width is 4 units. Okay, so which means that for the first part, if you want to find the area below the curve, since the region bounded on the y-axis, okay, so we need to integrate with respect to y-axis from 0 until 2 of the function x. So we need to make x as subject matter. Since we have y squared equals to 4 minus x, so therefore x, let me see, I will bring x to the left hand side becomes y squared plus x equals to 4. Therefore x is just equals to y squared, 4 minus y squared. So we have integration of 0 until 2 of 4 minus y squared with respect to y. Why with respect to y? Because the boundaries lies on the y-axis, minus, don't forget to minus with the area of the right angle triangle, which is just half times 2 times 4. It's just equals to 4 units. So solve the area under the curve, which is equals to 4y minus y to the power of 3 over 3 to 0 minus 4. So we will get first part here, 4 times 2 minus 2 to the power of 3 over 3 minus with 4 times 0 minus 0 to the power of 3 over 3 minus with 4. This produced from the integration. So from here we will get 8 minus 8 over 3 minus 4, everything. So final answer should be 1 over 3 unit squared. Okay. So now we have done integration as summation of areas, everything. We have looked at the area of region between the curve and x-axis, area of region between the curve and y-axis, and also area of region between the curve and a straight line. So next class I will go into volume of solid revolution. I hope you understand today's lecture. I'll see you soon. Bye.